We are coming to you live from here at the Spacecraft Assembly Facility at NASA's Jet Propulsion Laboratory. Now, JPL is known for robotic exploration of the solar system, and many of those robots were made right here in High Bay 1. If you were with us last week, you might have seen the NICE-R spacecraft. This is a NASA Indian Space Agency collaboration. It's an Earth science mission, and it is not the only spacecraft that's in here. Just this past weekend, we received much of the hardware for the Psyche mission. Now, Psyche is going to be headed to an asteroid of the same name in the main belt, and here to tell us more about the hardware that we're seeing today, what the mission will do, is Project Systems Engineer David O. Hey, David.
Hi, Stephanie. Pleasure to be here.
All right, so David is here to answer your questions, so be sure to keep those coming in the chat wherever you're watching, and we'll be answering live for the next half hour or so. We'll also be answering in the comments later on if you're watching this on demand. So I'm going to go ahead and start with some of the questions that have already come in. Tapaji Raj, you are all of us. He's got some great questions here about what Psyche is and what it's going to do. So what instruments are there and what are they going to do? What are their functions?
So the Psyche spacecraft is going to go visit an asteroid called Psyche, which is the largest metal asteroid in the solar system. And it's going to go try and figure out where it came from and how it was created and what it's doing there. So in order to do that, we have 3 different instruments on here. We have a magnetometer, which is a device that measures magnetic fields, which will tell us if it has a magnetic field around it. We have an imager, which takes pictures of it, which allows us to see what the surface looks like. And we have a gamma-ray neutron spectrometer, which allows us to determine the elemental composition of the surface by looking at gamma-ray emissions from the surface, which are caused by cosmic rays as they hit the surface.
All right, so you anticipated one of his follow-up questions is, will it take pictures of the asteroid?
Yes.
It's got an imager.
Yes, it will take pictures of the asteroid. It's got an imager on there made by the same company that makes some of the imagers that are on the Perseverance rover. So we're using that same camera technology to go take pictures out at this asteroid.
Okay, and when is the spacecraft slated to launch?
It's slated to launch in August of 2022, so about 1.5 years from now.
Fantastic. And what needs to happen between now and then?
Oh boy. Well, we've got the basic body of the spacecraft here. This contains the basic propulsion system and structure. And we need to put onto this the brains of the spacecraft. The computer is actually made here at JPL, and the software is made at JPL. So we're going to take that computer and that software, put it on board the spacecraft, and then we'll be able to test it with the science instruments, make sure it all works together, and then put it through a full test program where we take it and we put it in environmental test chambers. So we shake it on a vibe table like it's launching. We vibrate. We bake it in a thermal chamber. We expose it to liquid nitrogen level cold and to solar lamps which make it warm, so it'll be exposed to the heat and the cold of space. We want to put it through its paces here on Earth to make sure it'll work when we actually get to space. And after we're done with all that testing, we take it to launch base so we can launch it.
And where will we be launching from?
It'll be launching from Cape Canaveral, Cape
All
Kennedy.
right. And do you know what kind of rocket it'll be going up on?
Yes, it'll be launching on a Falcon Heavy.
Fantastic.
I think it's the first Falcon Heavy to go interplanetary, is what I recall.
Superlative. Okay, well, we don't have the rocket here today, but we do have a lot of the spacecraft. Do you want to just walk us through from left to right some of the hardware that we can see?
Sure. What you see here is what we call the Solar Electric Propulsion chassis. Just like the chassis of a car, it contains the structure and the propulsion system and really the power that makes it go. So if you look at it from left to right, what you see over here on the left, the big silver thing, is the main antenna. That's the high-gain antenna that allows it to communicate with us from hundreds of millions of miles away. Underneath it, there are 2 booms. One will support the gamma-ray spectrometer instrument. The other will support the magnetometer. We support those away from the spacecraft body, so they get clean views of the asteroid. And then as you move down from that, what you see is the main body. You can see a whole bunch of red boxes on there. Those are thermal louvers. Those red things are actually covers that we'll remove before we launch. But those are louvers which open and close to control the temperature of the spacecraft. And then on the side, that round thing you see there, that's where the solar arrays plug in, because there are 2 big solar arrays that go into this. You're seeing just a small part of what this thing looks like. When it's fully deployed, you got 5 big panels of solar arrays on each side, generating 20 kilowatts of power total near Earth. And that's what provides the power that goes with it.
So this spacecraft will use solar electric propulsion. Can you explain what that means and what's so innovative about it?
Sure. Solar electric propulsion is a type of advanced propulsion. We need advanced propulsion to be able to get into orbit around Psyche. And it's a type of system that takes solar power, which is converted into electricity, and takes that electricity and converts it into thrust. It does that by using electricity to ionize xenon gas, which is our propellant. That xenon gas is ionized, which charges it, and then it's put through a magnetic field and an electric field, which accelerate it out the back of the spacecraft. And by doing that, we can generate thrust so that we can operate the spacecraft in space and accelerate it, get it to go to Psyche, which is where we want it to end up.
So this is the same kind of propulsion system that we saw in the Dawn spacecraft.
It's similar to it. It's in the same general family. It's electric propulsion.
Okay.
The Dawn spacecraft used what we call ion thrusters, gridded ion thrusters, which is one way of doing this electric propulsion. This spacecraft uses a different type of technology. It uses Hall effect thrusters, gridless devices that use magnetic fields to hold electrons. And this will actually be the first time we've flown Hall thrusters beyond lunar orbit. So these are going to be the first time Hall thrusters have gone interplanetary in human history.
Fantastic. Okay, well, once you've launched, how long does it take you to get out to the main belt and get to 16 Psyche?
It takes about 3.5 years for us to get out there. So we launch in 2022, do a 3.5-year cruise. Then we take about 22 months at Psyche orbiting the asteroid itself to collect our science data.
All right, so this is not your first mission here at JPL, and I think you're in a unique position to be able to help Adrian out with his question. Adrian on Facebook asks, can you explain more of what's in this room? The attributes of High Bay 1 here.
So High Bay 1 is one of JPL's historic facilities where they've manufactured spacecraft for decades, certainly as long as I've been here. And you can see on the back there are a series of badges showing the various spacecraft which have been manufactured here at JPL in this high bay, which will go all the way back to Ranger. I think the year on that is 1961. Is that the year on there? It goes back to the beginning of the space age when the first space probes were being built. This is a big clean room facility. It keeps the spacecraft clean, keeps them from being contaminated as we build them. I was here when the Curiosity rover was built here. I think the Perseverance rover was built here last year before it launched, and now we're building Psyche here in this facility. And this is where spacecraft are born and where they're built.
Absolutely. So if as Gabby's been panning here across all of those icons there in the back, those mission patches in the back, they also include the Voyager spacecraft. All the Mars rovers were made here. So Perseverance and Curiosity, Spirit, Opportunity, Sojourner. This is a hallowed hall. And we've got a little bit more room, so we're still awaiting the installation of the Perseverance patch, and then next to that will be NISAR and then Psyche.
Yep, we'll be in good company.
Fantastic. Okay, so moving on to more questions. Everybody keep those questions coming. Jessica on Facebook wants to know, how do we know what Psyche is made of?
How do we know what Psyche is made of? Do we mean now or when we get there? Because those are two different questions.
Ooh, all right. Well, let's talk about what we know and what we don't know. And if we knew everything, there would be no point in going to explore, right?
Okay. So as of right now, what we know about Psyche, well, what we believe about Psyche is that it's made about 40 to 60% metal. And we deduce that from estimates that we've made of its mass, how much it weighs, and how big it is. And from that, we can deduce its density. And from its density, we can look at it and go, well, that thing seems pretty dense. So we can back out from that it's in the M class. It's a metallic class asteroid. Exactly how much metal there is, of course, we won't know until we get there. And so it's when we get there. First of all, when we get there, it'll be the first time that it ever looks to us more than just like a speck of light. Right now, when you look at it in a telescope, and I've looked at it in a telescope, and it's fun to look at, but it's really just a tiny pinpoint of light there. When we get there, we'll be able to take pictures of the surface. That magnetometer, if we detect a magnetic field coming from Psyche, that will be a sign that it used to be part of the inside of a planet. Because, well, the Earth has a magnetic field, but that magnetic field comes from the molten core that sits inside of the Earth, the iron core. And so if Psyche was once part of the inside of a forming planet, that it may have picked up those magnetic fields, have remnants of those magnetic fields that we can detect now, even billions of years later. What the gamma ray neutron spectrometer will let us look at it and determine exactly what's in that metal, whether there's nickel in there, whether there's gold, whether there's other materials. And from that, we can determine how it was created and what's in there. And then the imager, of course, shows us the surface. And by filtering those images, we can tell some of the surface composition of the surface by looking at the colors and the frequencies coming off of it.
So everything you've described with the instrumentation, this is all remote science. There's no actual contact that happens, right?
Not this one. We're not landing this time.
Well, Thomas wants to know, is it a one-way trip, and why not try to take a sample?
It is a one-way trip. We don't have the propellant on board to be able to come back, the fuel, in essence, to be able to come back. And we're not going to be trying to land and sample it because, quite frankly, we don't know what the surface looks like. We have never been to a metal asteroid before. Now, we've been to asteroids that are made of rock, and we've seen worlds like Pluto that have a lot of ice, and we've been to gas giants like Jupiter. But this is really our first time visiting a large metal body. So we don't know if we can land on the surface. We don't know if it's rocky. We don't know if there are craters. So we need to really consider this the first survey mission. We're going to go out and we're going to see what this thing is, see what it looks like. And then once we know more about it, we'll be able to send out a spacecraft that can land on it or take samples and do things like that. But this is really our first time seeing a brand new body. So it's a little early for us to try and land on it.
Well, okay, so when we get there, we go into orbit around Psyche. How long will we stay there? And will we stay at the same altitude? Will we stay at the same angle? Or are you going to change things up?
We will be there for about 21 months. And we will be on a series of 4 different orbits, starting way up high, going down low. The lowest orbit will be within about 1 planetary diameter. So it'll be within about 150 kilometers of the surface, 150 miles of the surface, I guess, about 200 kilometers of the surface. And it's in that lowest orbit that the gamma ray spectrometer can operate and take its elemental data. But before we can go there, we start in these higher orbits because we actually have to go, and as I said, we've never been to an asteroid like this before. We have to survey it. So we start up in a high orbit where we can determine what the gravity field looks like and determine what the stable orbits are present in the asteroid. And then as we learn that, we move to lower and lower orbits, making sure we can get safely to the lowest orbit that we need to do the science.
Well, one thing we haven't talked about is how big is Psyche?
Psyche is about, let's call it 125 miles in diameter. It's a little over 200 kilometers in diameter. It's about the size of Massachusetts. I think it's the distance between Tucson and Phoenix, a decent part of the size of Southern California. It's big. It's a big one. So imagine something that big that's made of 40, 60% metal. It's just huge.
Okay, all right, keep those questions coming in, everybody. Moon to Mars Quest on Facebook, we've got your question right here. Will available light at that distance be a restrictive factor for the imaging cameras on board? And what resolution will you be working with on those cameras?
The light is a big design factor in the cameras, but we design the cameras with big lenses so that they can operate in that lighting condition. Of course, we can only take pictures when it's light at Psyche. We can't take pictures when it's dark. An interesting thing about Psyche is that the Earth rotates and it has a night and a day. Well, Psyche rotates, but it's actually turned over on its side. So there are parts of its orbit where like one half is lit up and the other half is not lit up because it's kind of spinning like this and the sun is over there. And there are other parts where it has a normal night and day type cycle. So we have to sync up our spacecraft to arrive in such a way that we can get pictures of the whole surface so that we know that there'll be light covering the whole surface as it rotates. Otherwise, we end up with just half of Psyche. And that's much less fun than having all of it.
Exactly. Yeah, I'm looking forward already to 3D models made with the data that you'll have.
That's right. We build our own shape models off of that. 3D models that we then use to estimate the gravity, and we can figure out some things about what the inside of the asteroid looks like from that gravity field. So these are all important parts for the scientist in learning what Psyche is made of today and how it came to be.
All right. So at the top of the show, I mentioned that you're a project systems engineer. Can you tell us more? What does that mean in layman's terms, and how do you spend your days on the mission?
Sure. The project systems engineer, I'm the project systems engineer at what they call the Engineering Technical Authority. I and the team that I lead are a team of engineers that are in charge of making sure all the different pieces of the mission, the instruments and the spacecraft and the ground system and the rocket, will all work together to be able to accomplish the mission's goals. So we're in charge of eventually making sure that it all comes together and works together. Systems engineers are generalists. You know, they tend to operate in a whole bunch of different areas because you're pulling together all these different pieces. It's a lot of fun work. We get to interact with a lot of different people. Now, right now, under COVID, my time is spent in a lot of Zoom meetings. But I think normally we get to interact with a lot of different people and go down and see the fun hardware and things like that in trying to interact with everybody. What we do is we build teams. We build collaborative teams of engineers that work together to make the mission work.
And what was the path that you took to get where you are today?
Oh, well, I grew up in Alabama, actually, and I went to high school there, and I was good at science and math, but to be honest, I didn't even really know what engineering was when I graduated because I hadn't really met any engineers, didn't really know much about it. But I did get into MIT, and so I went there thinking I might be a scientist or a physicist or something, and then I discovered what engineering was. And so when the time just came to pick my major, I thought, well, I think space is something cool that maybe I could go work on, and building spacecraft would be neat. And I've been fortunate enough that I've been able to stay in the field since then. I got my PhD there, and then went and worked in commercial industry, worked on commercial satellites for Maxar, the company that makes the SEP chassis, building the types of satellites that carry direct TV and Sirius satellite radio, all the commercial stuff. And then worked there for 7 years and then came to JPL. And here I've been a system engineer working on the Curiosity Mars rover, and I work on mission proposals too, helping create missions like Psyche, which is one of the fun things that we do here.
So you've been on Psyche almost from the get-go, right?
Yes, I think that's right. I think I was the 12th or 13th person to join the project.
Was it just a cocktail napkin sketch at that point, or a whiteboard sketch, or?
Oh, I wish we had a cocktail napkin sketch or a whiteboard sketch. No, it was an idea. It was a set of goals. It was a destination. It was a set of science goals. But we had to go through all the work of figuring out what kind of instruments do we want to put on board to do this? How do we want to get there, chemical or electric propulsion? What should our spacecraft look like? How much power do we need? These are all things that we had to develop ourselves. I mean, I can remember this design here, which has the two towers and the big antenna up on top. I can remember when I and Peter Lord, who's one of the deputy project managers at Maxar, and Dan Goebel, who's the chief engineer, the three of us were sitting in my office at a whiteboard trying to figure out, okay, we need to tell the configuration engineers, what should this thing look like, right? And we were just drawing on the whiteboard trying to figure out where we should put the instruments and where we should put the antenna. And this is actually pretty close to what we put on the whiteboard in terms of its basic configuration. They did a pretty good job.
All right. Well, on that note, Gonza on Facebook wants to know, what is the main challenge that you faced in the development of the Psyche spacecraft?
We've had a lot of challenges in the development of the Psyche spacecraft, and there's so many different ways I can talk about that. You know, what we're doing here with this design in a technical sense is we're bringing together this propulsion and power system, which is built by Maxar, and then putting the JPL computer on top of that. And that requires a high degree of coordination and really close work between the two teams. So we spent a lot of time trying to build that team, understand all the technical requirements, but also understand the cultures of each of the organizations and bring them together. And then on top of that, you stack on COVID, which hit us a year ago, and the fact that we mostly can no longer meet with each other in person. The folks working on this hardware get to go down on the floor, but most of us are working from home and in Zoom meetings. It's been a real challenge trying to maintain that. But fortunately, the PI, Lindy, believes in building strong teams, strong collaborative teams, and that strong team that she built has been key, I think, to working effectively through this whole COVID pandemic thing.
So on the note of COVID, Jessica wants to know, how long will Psyche be at JPL? And do you think visitors might be able to see it post-COVID restrictions?
It'll be here a little bit over a year, and I think visitors will be able to see it. You can come up in the viewing gallery here or in the sister High Bay 2, where it will also be, and get to see it. You can't just walk up. Got to have a tour guide and all of that. But yeah, it should be here a little over a year, and then it'll ship off to launch base.
All right, well, I'll take that opportunity to say, Jessica, make sure you go to jpl.nasa.gov. You can take a virtual tour right now, then go on the floor of the clean rooms to get up close with NISAR. We took some pictures, 360-degree pictures with NISAR down there, and you'll get to see everybody in their gowns, their clean room attire, their personal protective equipment. And then in the after times, when restrictions have lifted, we will be taking tours again. But for now, everything's virtual, and you can find it there on our website, jpl.nasa.gov. Okay, back to the questions. Let's see. Ooh, Jessica also wants to know, was it difficult for you to transition from a Mars project to an asteroid project?
Oh, was it difficult to transition from a Mars project to an asteroid project? Well, so before I worked on Mars, I worked on commercial spacecraft, right? Communication spacecraft that go to geostationary orbit at Earth, and then went to Mars, and then went to this. I'd say yes and no. They're different. They do very different things, but the physics is the same when you're in flight, and the engineers that you work with, a lot of them are the same people. Not always, you're switching people around and whatnot. And the teams, the experience that you get building one spacecraft does translate to the building of another spacecraft. So it's not as different, I think, as you'd think.
Do you find cultural differences at all between teams working in different parts of planetary exploration?
Oh, sure. There are strong cultural differences, even within the project, right? When you're working, we have a team that's in Denmark, for instance, right? They have cultural differences and distances and language and things like that, but they still work with us closely. Early in my career, I worked with Russian vendors who were building rockets and stuff like that. They have a very different culture and how they do things there. Worked with the French also when I was working on communication satellites. It's all of these different people, all these different cultures coming together to build these things collaborative.
Fantastic. Well, we were chatting earlier about you being a fan of The Expanse, and I just think it's hilarious that you started as an Earther, you became a Martian, and now you're going to go be a belter.
Oh, I did all three. Oh, I thought you're the first person to point that out. That's fun. Uh-huh.
All right, Busman. Okay, back to the questions. Enough of my jibber jabber. Do you know Commander Galaga Champ? That guy's playing Galaga. Wants to know if any decisions have been made about potential public engagement, ways that people could participate in the mission. Will we be sending names along to ride on the spacecraft, or is there anything you can talk about like that? Yeah,
there's quite a few outreach programs, I think, that have been going for Psyche since we were selected as a mission. There's a Psyche-inspired program that people can sign up for, where you don't have to be an engineer for that one. People contribute artwork. People have contributed music. It's all part of the work that's being done by ASU as part of public outreach. I think there is going to be a program where people can sign their name and get that put on Psyche as well on a little microchip. And just keep an eye out for all the different things. Oh, there are also Psyche capstone projects, which are out there. If you're at a university, the Psyche project working through, I think it's ASU, has signed up different universities which are able to do little design projects that are engineering design projects that's associated with Psyche. So Google Psyche Inspired, Google Psyche Capstone projects, and you'll see plenty of stuff on there. Go to the Psyche website. There's plenty of stuff on there.
Fantastic. Well, I can't think of a better or more collaborative note to end on than that. You talked about your strong and collaborative team, which includes the members of the public. So everybody stay tuned. There's a lot more to come for Psyche. We're just getting going. Watch us here at NASA JPL, wherever you get your social media, to find out more about what's happening at the lab. And for the latest on Psyche, follow at NASA Solar System on Facebook, Twitter, and Instagram. Thanks so much for joining us today, everybody. We'll see you online.